Good morning, everyone. This will be your solutions video for quiz 4, which was due this morning. So just a quick reminder though, before we get started, you do have an exam tomorrow. And I noticed that in the last exam, a lot of you forgot to show your IDs. Make sure for this exam you show your ID. It might even prompt you for it, so don't forget to do that. And your exam will be posted by 8 o'clock tomorrow morning, and it will close at 11:59 tomorrow night. So make sure you take care of that. Okay. So let's go ahead and start on quiz 4 here, which is over lecture 5, the beginning of alkanes. And so quiz 4. The first question is name the parent compound or parent chain of the following compound. This is pretty easy. We have here the longest chain being this right here, which is actually an octane. Okay, and it also is the parent chain because it has the most substituents on it, 3 of them. So the answer there is octane. Okay, so here is named the IUPAC. What is the IUPAC name for this compound? Well, we know that we have an octagon here, right? So it's going to be an octane, and it's circular, a cyclo, so it's sometimes cyclooctane. Then the question is, how do we name the substituents? Well, we'll number it first based on the fact that this is called a tert butyl or butyl group, and this is a methyl group, right? So the substituent with the alphabetically, the substituent with the name alphabetically first will get the first locant or the first number, and so in this case butyl will be it. So 1, 2, 3, 4, 5, 6, 7. Whoops! Try that again. I don't know what how did I count that there? That's just crazy. 1, 2, 3, 4, 5, 6, 7, 8. I skipped one of the carbons. Anyway, so that's how we'll number it, right? And so we number it that way. We have 1 tert butyl, right? And then 3 methyl cycloheptane. Okay, and that would be 1 tert butyl, 3 methyl cyclo. Sorry, not heptane, octane. The first time I counted it, it was 7 because I missed a carbon, but it's actually 8 carbons, so it's octane. The answer here is E. Don't miss your carbons when you're counting them, right? Okay, so next one is define or which of the following compounds are the constitutional isomers, right? First thing to note here is that it says compounds, so it's more than one. But then as you look at these things, right, it's quite easy to see that, for example, this one right here, okay, it's actually got 2 less hydrogens. Two less hydrogen atoms than this one. Okay? Right? So those two can't be the constitutional isomers of each other. And then when you look at this one here, and I'm just choosing the first one because it's the first one there, so I'll compare everything back to the first one. This one here actually has 1 less carbon, right? There's no methyl down there, whereas this one has a methyl down there, so that's 1 less carbon. 1 less carbon atom. Okay? So it can't be those two, right? But now you're just left with this one left. So you can easily just cross those two out and know that there's only 2 left and those 2 are the constitutional isomers. But we can always make sure. Let's count the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 carbons, right? That's good. Everything is open here, and everything is open here as well, so they have the same number of hydrogens, right? And so the answer would be structures 1 and 4. E. Identify the size of hydrocarbon that would be used in natural gas. Well, we all know that's actually methane, right? CH4. So that's what natural gas is, and so the answer is A. 1, 2, 4 carbons large. Excuse me. Next one, number 5. Which of the following is the correct Newman projection for the following compound as viewed from the indicated bond in the conformation shown? Okay, so as you're looking, as your eye is there and looking down this bond axis right here, right? Pretend that your eye is actually in the sheet of paper, right? And you're looking down that bond axis. You can already tell then that since this chlorine here is solid wedged, right? It means it's coming out of the paper, right? So it's as you're looking at it, it's going to be on the left side, right? And so that means on the other side here, with the dashed line, even though it's not there, is a proton. Okay? So just from that alone, knowing that the chlorine has to be on the left side, right? You already ruled out structure 1. Chlorine is definitely not pointed down, right? Because it's coming out of the paper, so it can't be structure 3. This one's got methyl in the left position, pointed down, so it can't be that one. So it's between this one and this one. So the other thing to notice too is that while chlorine is coming out of the piece of paper, right? And if you're looking straight down that bond, it's going to the left because of a solid wedge. The fluorine over here has a dashed wedge, which means it's going back into the piece of paper. And if you are on the piece of paper looking down that bond, that fluorine is actually going to the right. This has fluorine and chlorine on both the same side, right? Both of them are on the same side on this one, so it can't be that one. So that's why your answer is structure 2, B. Okay. Next one. You'll get better at visualizing these things like in your head, okay? Especially if you have a molecular model kit available to you. All right. So which of the following is the correct wedge dash structure for the following Newman projection? Same thing again as you did on the last one. Here, you see that pointing downwards is a chlorine at the diagonal. There's a chlorine and a methyl, and at the very bottom, like that's still on the sheet of paper, right? That's in the plane of paper is a methyl. Okay, so first thing you notice is that there's a chlorine on the right. If the chlorine is on the right, that means, and you're looking at it down the bond angle from the sheet of paper, and it's on the right, that means when you're looking at it from the side, from the top of the piece of paper, then the chlorine should have what kind of wedge? It should be a dashed wedge for it to be going to the right, right? So you already rule out this one, because that's not a dashed wedge. You rule out this one because that chlorine is pointed upwards, not downwards, right? And then you also rule out this one because that one is not a dashed wedge. Okay? So that leaves you with these two right here. Which of these two? Okay? Well, this is pretty simple. On the Newman projection, chlorine and methyl, the methyl group, are on the same side, right? So that means they both need to have dashed wedges, right? The only one that has that is structure 2, right? Because over here in structure 4, it's got a solid wedge, which means it's on the other side of chlorine. It's like opposite chlorine. Okay? So the answer here is 2, or structure 2B. Okay? And okay, so now we get to question number 7. And this, again, this is totally my fault, my bad here. We're covering so much information so fast, I forget what I covered in the lecture as I'm writing these quizzes. And so, a couple of things here to note. So, questions 7 through 10 are actually for the next quiz. And so, to rectify that situation, right, I'm just going to make it where, since it's 4 questions that weren't supposed to be in the quiz, I'm just going to give everybody 40 points for that quiz, right? It doesn't matter if you get the question right or wrong. Everybody across the board will get 40 extra points on this quiz. Okay, just to make up for the 7 through 10 that I royally screwed up there. Another royal screw up here too is that for some reason when I type this, I typed in hexene, which is a cyclohexane with a double bond. Okay, so yeah, that's wrong there. That should be definitely be cyclohexane. Yeah, so there's a number of things wrong with this quiz, but just for the purposes of practice and your exam coming up, right, tomorrow, let's go ahead and answer these questions. Well, this one's pretty easy. What identify each substituent as axial or equatorial? You should actually be getting this stuff right now or today in lecture, okay? And no, sorry, you should be getting it yesterday. You should have gotten this stuff yesterday in lecture already. And I've already forgot what day it is. And both of these here, the fluorine and the chlorine, are in the equatorial positions. Okay, they're in the equatorial positions, right? If they're pointing out to the sides. If they're pointing up like this or something like that, that would be axial. So the answer here would be fluorine equatorial, chlorine equatorial. So the answer there is C. Which of the following is the most stable conformation of cyclohexane? Remember that from it was either yesterday's lecture or today's lecture, I can't remember. Cyclohexane is most stable in the chair conformation, right? That's the one that gives it the least amount of steric hindrance, right? This is not a conformation, that's just a flat drawing. This is also a flat drawing of it in the Hayworth projection, so none of those, that's not a conformation. These definitely are conformations, right? But this is a twisted boat conformation that's not stable, and then this is also a boat conformation that's not stable because you have the two CH2s up here, right? They're both close to each other, much closer than they are if they were in the chair conformation and completely, opposite of each other, right? So the answer here is C, structure 3, right? Okay, so on each chair structure, identify the relationship between the substituents as cis or trans. Remember that cis means they're on the same side, and then trans means they're opposite each other, right? So this is pretty obvious here. These two here are on the same side. These two here are opposite of each other, right? It's that easy. Don't think about it too hard, right? I just said that this was. I just thought about that, and I said that was on this. They're both opposite of each other, so my bad. I think I misspoke. Okay, don't think about this too hard. Let me just say that again. Don't think about this too hard. But they're both on the opposite side of each other, right? They're not on the same side of each other of the cyclohexane ring, right? So both of these would be trans. So the answer there is A. And then identify the most stable conformation of trans 1,4-diethyl cyclohexane. And again, I forget if this was in yesterday's lecture or the day before's. I don't think it was in today's lecture. But they're the most stable cyclohexane chair conformation with substituents, two of them, will be the one where the most substituents are going to be in the equatorial position. So you have one in the axial position there, so it can't be that one. One in the axial position there, can't be that one. This one is actually in the equatorial position, but the problem is that it's closer to this one than this guy is, right? This one's further away. This one's in the axial position right here. So the answer to this one would be number 3, C. Okay. And that ends today's quiz. I'll be available on Teams today for you to ask questions. If we need to meet over video chat on Teams, we can do that. I already have someone scheduled to meet with me today at my office hours, so which is 4 o'clock to 5 o'clock. So make sure you, if you need to meet with me, email me or get on Teams and we can try to work something out. Good luck on your test tomorrow.